Hello? Hello? Ed? Can you hear me?
Are you getting through now? What did you say?
Nothing. Hello? Hello?
By the early 1900s, the telephone had established its importance in the fabric of business and social life. The telephone network was expanding at an accelerating pace on a worldwide basis. This program will feature the early telephone developments of what has become known as the Magneto Era. Prior to the telephone's invention, the only means of electrical communication was the telegraph. This required specially skilled operators using complicated equipment to encode messages sent over miles of wire supported on wooden poles to the distant station. Replies were seldom instantaneous, but nonetheless the telegraph opened up remote areas to trade and commerce and facilitated the development of colonies. Telegraph technology also provided the means for experimenters to begin investigating the possibility of sending actual voices directly over wires. Alexander Graham Bell, a professor of vocal physiology, taught speech to the deaf and dumb in the 1870s. And through his interest in telegraphy, he had by 1874 conceived an idea for a speaking telegraph. Assisted by Thomas Watson, an instrument maker, Bell was working at the Charles Williams workshops in Boston on telegraph improvements. And on June 2, 1875, during experiments, Bell discovered the principle by which speech could be sent over wires. By the next day, Watson had constructed the first practical instrument, known as the gallows telephone. It consisted of an electromagnet mounted in a wooden frame, the armature being connected to a non-metallic diaphragm via a piece of cork. The hollow end of the frame formed the mouthpiece for the concentration of sound waves. For the experiment, the gallows was connected via wires to a battery and an electromagnetic receiver. The result was not as successful as he anticipated, but provided sufficient incentive for a patent. Further experimenting led Bell to use a liquid transmitter based on a variable resistance theory. The device had a voice-operated diaphragm with a wire attached to it, and the other end dipped into a cup of acidulated water. This movable wire formed part of the electrical circuit with the battery source and the electromagnetic receiver. The 10th of March 1876 is recorded as the day when Bell pronounced the now famous words, "Mr. Watson, come here, I want you," to his assistant in another room. The telephone was now a reality. With news of Bell's success, rival inventors soon put forward their claims. Elisha Gray, a superintendent of Western Union Telegraph Company, on the same day as Bell, filed a caveat on his own similar ideas for a telephone instrument. After lengthy courtroom battles, Bell was credited with being the first to transmit articulate speech in a practical way, and thus held the most valuable patent ever issued. The 1876 Centennial Exhibition at Philadelphia allowed Bell to display his newly developed telephone instruments. Among these was one known as the Centennial Magneto transmitter. For commercial reasons, he reverted to an improved electromagnetic instrument consisting of single or double-pole electromagnets in conjunction with a non-metallic diaphragm that was stretched over a metal cylinder. Also exhibited was the Centennial iron box receiver. The publicity from this exhibition enabled the launch of his first commercial telephone in 1877, known as the box telephone. In this, Bell replaced the electromagnet and battery with a horseshoe-shaped permanent magnet. 2 coils were attached to its poles by soft iron pieces, and the diaphragm was of thin iron. In operation, incoming sound waves vibrated this diaphragm, causing fluctuations in the magnetic field. This induced a varying current in the coil that was in sympathy with the original sound waves. Watson soon after introduced a mechanical thumper as a calling device, which struck the diaphragm to gain the attention of the called person. This replaced the tapping of a pencil previously used. Bell used public demonstrations to promote the advantages of his telephone in comparison with the telegraph. However, the telephone did require loud shouting and repetition of words at this early stage. To improve the portability and ease of use, Bell developed a more compact handheld telephone known as the butter stamp because of its shape. The butter stamp of 1877 took 4 basic forms as it was being refined. Housed in a turned wooden case, it used a single-pole permanent magnet with a small coil and a thin iron diaphragm. Although the telephone was still in its experimental phase, the public were impressed by Bell's demonstrations, convincing them of his invention's superiority over the telegraph. The growing popularity of the telephone in America soon spread into Britain and Europe, spurring other experimenters and manufacturers to develop their own variations. Werner von Siemens Company manufactured and sold their telephones, which were widely used throughout Germany and parts of Europe. The construction of the Siemens Halske instrument was of a high quality, and their designs featured a stronger and more efficient horseshoe magnet that gave better transmission, particularly over longer lines. Lars Magnus Ericsson of Sweden, whose company would later become a world leader in telephone design, initially made variations of Bell and Siemens telephones. However, even the most advanced of these early instruments had shortcomings which soon became apparent, and strenuous efforts were made to improve the equipment and the procedures of use. For example, the first telephones were installed in pairs and communicated only with each other. One telephone instrument served as both a transmitter and a receiver. The difficulties here were obvious, and the provision of a second instrument on each installation eliminated the constant changing from mouth to ear. Also, different forms of signalling were now being added, such as the rattling of bells and even the blowing of whistles or small trumpets into the mouthpiece. Further developments made use of electric buzzers or direct current bells using a battery and a press button switch to initiate the call. These were only useful over short distances and required constant attention to the battery. A manual changeover switch was used to connect either the telephone or the bells to the line, but this placed heavy reliance on the memory of the user. In 1878, Watson developed a Magneto bell system that would be adopted universally as the main form of signalling. It made use of his call bell or ringer that was powered by alternating current produced from a hand-cranked magneto generator. Bell's next commercial telephone, now known as a Williams coffin, featured all these new improvements with the addition of lightning protection on the line. To eliminate the problem of remembering to return the switch to its proper position, Hilborn Roosevelt invented a gravity switch device to automatically change between the telephone and bells when the receiver was lifted or replaced. The famous American inventor Thomas Edison recognised that the basic weakness of Bell's telephone was the inefficient transmitter. Through practical experimentation, in 1878 he was to become the first to successfully produce a variable resistance transmitter, which used a button of lampblack for the resistance element. Edison also improved the performance of his transmitter over longer distances by using an induction coil. This meant the resistance of the circuit containing the transmitter could be kept very low, and the relative variations in current made larger by the transformer action of the coil. Edison marketed his superior transmitter through a company competing with Bell. Avoiding patent infringements, he developed an ingenious form of receiver that required the constant cranking of a handle for its operation. In the meantime, a Professor Hughes of London had in 1878 published investigations into what he called the microphone effect. His discoveries related to the resistive variations between any two or more loosely connected electrical conductors across a battery when vibrated by sound waves. It was not long before Francis Blake of America and Lewis Crossley of England produced practical telephone transmitters based on Hughes' work. By late 1878, Blake's transmitter was introduced by the Bell Company as an equal to Edison's. It consisted of a metallic diaphragm mounted on an iron frame. A large adjusting screw varied the contact pressure of a pellet of platinum, fixed to a leaf spring between the diaphragm and the carbon button, which was also supported by a spring. Blake's transmitter was very successful and reproduced speech clearly, and though it was insufficiently powerful for long distances, it nonetheless outproduced every other sort of single contact transmitter due to its use by the Bell Company. Lewis Crossley developed the first practical multiple loose contact transmitter in early 1879. It made use of 4 carbon blocks mounted on a thin pine sounding board which formed the diaphragm component. Between the blocks, 4 carbon pencils were placed with their ends turned down to fit loosely into holes. The 2 outside blocks formed the electrodes for the electrical connections. This transmitter was more powerful than Blake's, but was subject to annoying crashes if the vibration on the diaphragm was too severe. Improvements in carbon pencil transmitters consisted mainly on increasing their efficiency by adding more pencils, and hence increasing the number of loose contacts. Crossley transmitters and other variations were mainly used in Britain, while Clement Ader's designs were extensively used in France and Europe. However, in 1878, another Englishman, Henry Hunnings, patented what would become the mainstay of all practical telephone transmitter designs well into the 20th century. Introduced onto the market in 1881, initially enclosed in a handheld wooden case, this was later refined and housed in an ebonite container. His idea was to use a quantity of crushed carbon granules placed in a cavity between 2 electrodes, one being a fixed carbon plate and the other a platinum foil diaphragm. These granules formed thousands of loose contacts as they lightly touched each other, and the strength of a current passing through them via the 2 electrodes was efficiently varied when sound waves vibrated the diaphragm. The Hunnings transmitter was superior to any others so far, but early designs suffered a serious loss of power due to the carbon granules packing down into the bottom of the case. To alleviate this problem, W. Deckert of the General Electric Company cut the back electrode into a pattern of small pyramids. This was combined with a redesigned case and introduced a mounting setup which encouraged the user to occasionally rotate 180 degrees by hand. In this form, the Hunnings cone decet, as it became known, endured for over 30 years and was still listed in catalogues of the 1920s. L.M. Ericsson's company also designed transmitters. The first was known as the helical transmitter, being a variation of the Blake in a compact housing. And by the mid-1880s, it was manufacturing transmitters using carbon granules. These were highly efficient, giving clear, soft tones, and required little battery power. This early design used a carbon block with concentric valleys to contain the granules. This was later superseded by a new design forming a star chamber arrangement, which proved to be more powerful and became highly successful. 1890 saw an American, Anthony White, refine the Hunnings cone design into an extremely high-powered and efficient transmitter, utilising a tiny moisture-resistant capsule built on the Hunnings principle. This became known as the White solid back and had become nearly universal in American telephone designs by 1920, as well as being widely used around the world. Of course, these efficient transmitter designs were paralleled by improvements in Bell's original handheld receiver. Whilst the butter stamp functioned quite efficiently and was widely adopted, the strength of the permanent magnets was problematical, and the critical distance from the magnet pole face to diaphragm tended to vary with temperature. In the process of improvement, the case design became more practical, with hardened rubber or ebonite replacing the original wooden housing. To ease temperature expansion problems, the magnet was fixed by a screw between the terminal connectors. These new designs would be called long pole receivers. Further development replaced the single pole with a double pole magnet designed into a shorter case. This case was made of metal and covered with an ebonite sleeve. Generally made by the Western Electric Company, they are called outside terminal receivers by view of their exposed connectors. The Ericsson design was of similar construction, but fixed their magnet from the sides using two screws. An American, G.M. Phelps, earlier experimented with alternative magnet arrangements. His crown and double crown receivers of 1878 showed little significant improvements in return for their bulky shapes. Eventually, the size was reduced and finally settled for a single curved magnet, which doubled as a handle. These were later adopted by the Western Electric Company in 1880 and named the pony crown, pony being an American term for small or miniature. Frederick Gower of England developed a receiver using a specially designed horseshoe magnet arrangement with two coils and a metal diaphragm, all enclosed in a cylindrical box. This receiver was later slightly modified to adopt the use of two listening tubes, which were a characteristic feature of his telephones. Some other designs even made use of a magnetic coil housed in a wooden case. Other variations in designs were also developed by manufacturers as alternative handheld receivers. In France, Ada in 1879 developed a powerful receiver by adding a large ring-shaped magnet, doubling as a handle, to the outside of the case. Eventually, this was reduced in size with a modified magnet arrangement to become a standard design size for many years. A popular and lightweight design were watch case receivers. Smaller and less powerful, they used a double pole magnet and were originally built for use over short lines or intercom phone systems within one building. Ericsson's also made their designs such as bull rings as an additional receiver for the telephone user, and a handheld spoon receiver as an alternative to their bell-type receiver for local line applications. Ericsson produced a variation of this theme in his famous handset design of 1892, which was very efficient on lines of all lengths and much in demand for over 30 years. The flourishing development of the telephone's transmitter, receiver and other essential components gave enormous impetus to communications, as by early establishment of manual switchboards for local connections soon grew into a network of large manual exchanges. Here, operators busily connected hundreds of calls as indicators and line cords displayed the subscriber's demands. This progress was also reflected by scenes of streets and rooftops cluttered with wires that formed the vital link between commercial business and the rest of the community. Australians accepted telephone communications very quickly. In fact, William Jackson Thomas of Victoria in 1878 constructed one of the earliest locally made telephone instruments after reading about Bell's invention from a Science magazine article. John Edwards Colonial Exchange Company manufactured his own telephone instruments and provided the first permanent commercial telephone installation in Australia. An example is this 1880s telephone, which features handheld receivers and a variation of a Blake transmitter. Companies formed by Thomas Draper and William Masters became very successful in selling telephones and associated electrical products, as their catalogues stimulated the importing of many American, British and European telephones. The Melbourne Blake was one of the earliest telephones supplied by the Bell Company around 1880. Consisting of two separate boxes, the top box housed the Blake transmitter and induction coil, while the box below housed this very early magneto generator to operate the ringer, with its distinguishing flat dome gongs. Also provided was a Phelps Pony crown receiver and its specially designed switch hook arrangement that was a variation of the manual and gravity switch. Some Blake models, originally sold in New Zealand, also found their way to Australia. These, however, were mounted in a different configuration and display later model generators. The Gower Bell telephone of the early 1880s was commonly used by Australian state administrations and the railways. Easily recognised by its bulky shape, its distinctive feature was the provision of two flexible listening tubes that were placed on switch hooks either side of the transmitter housing. This transmitter was mounted below a wooden panel and consisted of 8 carbon pencils arranged in a star pattern. A characteristic of many early telephones was the practice of concealing the wiring in saw cuts on the backboard. A telephone made by Hughes was introduced to New South Wales, Queensland and Tasmania in the early 1880s. This particular instrument used an early Bell patent receiver design. The box contained 3 carbon rods arranged in a Turnbull transmitter layout. The basic, almost primitive construction was typical of many limited production early telephones. A traditional American design introduced from 1882 was the triple or 3-box telephone. Manufactured by Western Electric in America and Britain, other companies also made similar models. It consisted of 3 separate boxes. The top box accommodated the magneto bell, long pole receiver and the switch hook. The switch hook design being an improvement on the Roosevelt type in disconnecting the transmitter's battery supply while not in use. The middle box usually contained the transmitter and induction coil, while the lower box housed the batteries underneath a wooden cover that also formed a writing slope. Twin box models were introduced later and were widely manufactured by numerous companies. These designs combined the transmitter with the other associated components into one compact box, thereby reducing the telephone's cost and overall size. The top box layouts were generally similar, whereby the ringer and transmitter were mounted onto the door, and wiring via the hinges made the electrical connections to the magneto, coil and switch hook, which were contained inside the box. Twin boxes were supplied with many varieties of transmitters, such as the Blake, Hunning's cone, and other component variations. The fitting of magneto generators also varied, some using a friction drive setup, while others installed the more conventional toothed gear arrangement. Lightning protection was generally a common feature of most early telephones. As with the triple box, the lower box housed batteries and provided a writing slope for the telephone user. Many small compact telephones also became available for short-distance applications, and although very popular, they did require a separately housed local battery for their operation. A French design, made by the Société des Téléphones of Paris, was introduced in mid-1880s. This became known as the Berthon Era. This telephone features one of the earliest combination handset designs. 2 Ada receivers were provided, one as an extra receiver, the other being on the handset, which also featured a large and very efficient carbon granule transmitter designed by Berthon. The magneto generator used was quite powerful, and its performance was improved by helically cut gear teeth, which were claimed to run quietly and wear longer. Well suited for Australian conditions, it was successfully adopted by the railways and state governments. Ericsson wall telephone designs were very successful in Australia due to their high quality of workmanship and ornate appearance, reflecting the Edwardian period. Early Ericsson models were of a pulpit design, ranging through many sizes and configurations. Supplied with a separate transmitter and using 2 receivers, it was constructed with an integral writing slope, so as to house the generator and other components conveniently, the batteries being below behind a metal cover. Later models introduced a handset design in many varieties, suiting local and long-distance applications. The PMG adopted one of these models as their standard issue, known as the Commonwealth Ericsson. An American desk telephone made in 1890 is known as the Western Electric swing arm. Using a solid-back transmitter supported on a swivel arm, it could be rotated either 180 or 360 degrees to allow its use from either side of a desk. The main components in this model were similar to the Western Electric twin box, but were suitably housed for tabletop use. Ericsson's introduced a wide range of desk telephones for local use that featured a high degree of quality and style. These designs featured attractive transfers, and each component was specifically designed to be both functional and aesthetic. The skeletal model, introduced in 1892, is a successful example. The main body housing the magneto generator, an ebonite block containing the wiring connections and the bell assembly. These were supported by 2 legs that formed the magnets for the generator. The handset was supported by a cradle, which also performed the switch hook functions, and the wooden bobbin above the ebonite block concealed the induction coil. A variation known as the Eiffel Tower was introduced by the British Western Electric Company. It was heavily decorated with floral design transfers, and some deluxe models featured an ornately carved hand grip. Many of these telephones were used in Australia. However, the Ericsson handset was later substituted. The British Post Office skeletal design features a slightly different terminal connection layout and was popular in Britain but seldom used in Australia. In 1893, the Ericsson company built a classic design known as the biscuit barrel, only produced in limited numbers. It was a prestige symbol used by Australian dignitaries and senior heads of government, and has become quite famous due to its rarity. The telephone's construction made use of the handset on a cradle, a lightweight 2 or 3 bar generator, and associated components, all concealed by a metal cover made in 2 halves with highly embellished transfers, while the base and top section was lacquered wood. Compactness and portability were always desirable, and American designers came up with the desk stand configuration, now known as the candlestick. The essential parts for the user are all arranged around the vertical stem, which was connected by cords to boxes containing the bells and signalling equipment. Produced worldwide in a myriad of varieties, this pattern has become an icon of the period. And so, in a space of about 30 years, a scientific toy and academic curiosity has become a vital part of personal and business life. Surviving examples convey not only a sense of living social history, but also a real link with a young and developing technology. Among the many pioneers of this communications revolution, Alexander Graham Bell, teacher of the deaf and inventor, stands as tall as any. And it is to him and his fellow pioneers that we pay tribute today.